हेलो एवरीवन, स्वागत है आप सभी का मेरे YouTube चैनल में। टुडे वी विल लर्न अबाउट Poisson distributions and in last class we learned about Bernoulli's theorem and Bernoulli's distributions. I hope you guys understand my last class and in this class we will learn about Poisson distribution. So let's start Poisson distributions. Now see Poisson distributions. Poisson distributions or probability distribution both are same. Name is different but both are same only. Poisson distribution is when used when n is very large. N is very large means n is tending to infinity, and p the probability of success is very less, p tending to 0, so that np tends to a fixed finite constant say m equal to np. M means mean formula of mean is np. When we use Poisson distribution, when n is very less, n is tending to infinity, and p is tending to 0. In these conditions, we use Poisson distributions. In these conditions, we used Poisson distributions. What is the formula of Poisson distributions? The formula of Poisson distribution is p of x equal to m p power x e p power minus m by x factorial. E is here exponent. The value of exponent is 2 p power 7. This is the constant. What is the formula? P x equal to m p power x e p power minus m. What is m here? M is mean. X factorial. M is mean. And what is the formula of mean? M equal to np. N is number of trial and p is probability of success. So for finding Poisson distributions, first we have to find m means mean. If we find the mean, then we can easily put the value of mean in this formula and we can get the answers. Okay. Now for this one conditions is there, p of x is greater than equal to 0, and the second condition is summation of px equal to 1. We have to remember this formula only, px equal to m power x e power minus m by x. If you know this formula proper way, then you can easily solve the problem based on Poisson distributions. Okay. Now see mean and variance. For this Poisson distributions, mean and variance is same only. What is the formula for mean? np. And variance is also same. Formula is np. And standard deviation is under root v. Under root v means under root variance. Under root m, under root np. Okay. Now we know that mean equal to np. Okay. So p equal to m by n. We can write m equal to np. So we can write p equal to m by n. Okay. Now we know that before only p plus q equal to 1. P plus q equal to 1 means probability of success plus probability of failure equal to 1. So here probability of success plus probability of failure equal to 1. Okay. So we can write p plus q equal to 1. P plus q equal to 1. So we can write also q equal to 1 minus p. And we know the value of p. P is m by n. So q is also in the form of m. Q equal to 1 minus m by n. Okay. This is the formula for Poisson distributions. Remember this formula and keep in mind when we use Poisson distribution. Poisson distribution is used when n is greater than p, or we can say n is tending to infinity or p is tending to 0. Or we can say n is always greater than p. And when we use Bernoulli's theorem, Bernoulli's theorem is used when p is greater than n. This is the difference between Bernoulli's and Poisson distribution. This is for Bernoulli's. And this is for Poisson distributions. Okay, now we move towards problem. Now see the first problem. First problem said that in a certain factory turning out result, there is a small probability of 1 by 500. A small probability means what? P. And before only I said p is very less. So small probability means here p. Small probability is 1 by 500. For any blade to be defective, the blade are supplied in a packets of 10 Use Poisson distribution to calculate the approximate number of packets containing no defective, one defective, two defective blades in a consignments of 10,000 packets. Okay. Now see here. They'll give P equal to 1 by 500. Okay. And N is what? N is 10, means number of trials. By using this one, P is given 1 by 15, 500, N is 10. So mean equal to M equal to NP. 10 into 1 by 500 means what? 1 by 50 means mean equal to 0.2. Mean equal to 0.2. Now we use Poisson distribution. What is Poisson distribution formula? Px equal to m p power x e p power minus m by x factorial. We know the value of m, right? Now in first question, see, in first questions, no defective. No defective means what? X equal to 0. No defective means x equal to 0. So probability of x equal to 0 equal to, in the place of m we put 0.02, and in the place of x we put 0, and e power minus, in the place of m we put 0.02 by x factorial. X factorial means 0 factorials. Okay, and remember this one, 0 factorial is always 1. Now after solving this one you get 0.9802. 0.9802. But in questions, what they said, consignments of 1000 packet. Okay, consignments of 1000 packets. So we have to multiply with 1000 at last. See, 0.9802 into 10,000. After multiplying 10,000, you got 9802. 9802 means 9,802. Okay. Now second problem. One defective. One defective means x equal to 1. One defective. One defective means p of x equal to 1. So we know the value of m, right? We know the value of m. We know the value of x equal to 1. Simply what we have to do, we have to put the value in the equations and we get the answers. Formula is px. Remember this formula, px equal to m p power x e power minus m by x factorial. If you remember this formula, use this formula and put the value and get the answers. Simply. See, in the place of m we put 0.02 and in the place of x we put 1. And after getting this, after putting the value, we get the value of, after putting the value we get this one. Okay. But in questions what they said, consignments of 1000 packets. So we have to multiply at last with 1000 also. So after getting this one, we have to multiply with 1000. So I will multiply here with 1000. After multiplying with 1000, we get 196.04. 196.04. So approximately 196. So probability of x means probability of one defective equal to 196. Now the third part is two defective blades in a consignments of thousands packets. Okay, two defective. Two defective means what? Two defective means x equal to 2. Okay, or we know the value of m equal to 0.02. Simply we use the formula of Poisson distributions, px equal to m power x. See, px equal to m power x e power minus m by x factorial. By using that formula, we put the value. After putting the value, you get the answers. This one and consequence of 10,000. So at last you have to multiply 10,000 here, and after solving this one, you can get 1.964. This is approximately equal to 2. So probability of x equal to 2 is equal to 2. Means defective number of defective is 2. 2 defective left. See these questions 1 second. Try to solve by on yourself. Now questions number 2. Now see questions number 2. Questions is the number of accident in a year to taxi travel in a city follows a Poisson distribution with mean 3. Here they directly give mean, means m equal to 3. out of 1,000 taxi driver, find approximately the number of drivers with no accident in a year. No accident in a year means x equal to 0. No accident in a year means x equal to 0. And more than 3 accident in a year means x greater than equal to 3. Sorry, more than 3 accident in a year means x greater than 3. Okay, this is the Poisson distribution formula. Px equal to m p power x e p power minus m by x factorial. So by questions only we know the formula, we know the value of m. Okay, and in first conditions, no accident in a year. No accident in a year means what? P x equal to 0. So we use the formula and we put the value. In the place of m, we put 3, and in the place of x, we put 0. After putting the value, you got 0.05. 0.05. But here they are talking about the 1,000 taxi driver. So at last we have to multiply with the 1,000. We got the answers p of x equal to 0.05, right? So they are talking about the 1,000 taxi driver. So we have to multiply with the 1,000. After multiplying 1,000, we get p of x equal to 50. Okay. Now see the second. More than 3 accident in a year. More than 3. More than 3 means what? X is greater than 3. X is greater than 3. So x is greater than 3 means what? X equal to 4, x equal to 5, x equal to 3 up to 1,000. X equal to 4, x equal to 5, x equal to 6, x equal to 7 up to x equal to 1,000. So we use formula p of x equal to m p power x or e p power minus m by x factorial. m p power x m p power x e power minus m by x factorial. So we use formula for p4, p5, p6, p7, p8, p up to 1,000. So this is very lengthy process. So we can't do this. So we can't use this process. So we use our brain. The range of probability is 0 to 1, right? 0 to 1. So we use maximum means what? 1. And ma- we use maximum 1 and we have to minus what we don't want. Okay. In 1, we have to minus what we don't want. So 1 minus p of x less than equal to 3. P of 1 minus p of x less than equal to 3. So 1 minus less than equal to 3 means what? P of 0, P of 1, P of 2, P of 3. Now the benefit is now we have to now we have to apply Poisson distribution only for 4 times. For P of 0, for P of 1, P of 2 and P of 3. See here in this one we have to apply Poisson distribution almost 996 times. So here this is the benefits to use this common sense. 1 minus p of 0 plus p of 1 plus p of 2 plus p of 3. So 1 minus, we know the value of m. In questions only they give m equal to 3 and p of 0 means here x equal to 0. So 3 power 0 e power minus 3 by 0 factorial plus now here m value of m is same for x equal to 1, not x equal to 1, for here x equal to 2, x equal to 3. After solving this one, if you solve this one, after solving this one, you get the value of this one 1 minus 0.1 minus 0.65 equal to 0.35. Okay. See here. Now number of drivers out of 1,000 with more than 3 accidents in a year means more. Here they are talking about 1,000. No, so at last you have to multiply with 1,000. 1,000 into 0.35. So the correct answer is 350. 350. Second question is completed. Now third questions. This question you try on yourself, and if any problem is there, then keep comment in comment box. Try it. These questions you try on yourself. Okay. Now see these questions. This is question number 4. Okay. Now 2% of fuses manufactured in a form are found to be defective, find the probability of box containing 200 fuses contains no defective fuse, 3 or more defective fuse. See here. Here in questions only they are talking about the defective fuse. So defective fuse, they are talking about defective fuse. So our defective fuse is only become a probability of success. Okay, because they are talking about defective fuse. So here P is what? Probability of defective fuse means probability of success, and probability of success is how much? 2%. 2% of defective fuse manufactured by a firm are found to be defective. Find the probability of a box containing 200 fuse. And the number of trials is how much? 200. So probability of defective fuse is 2%. 2%. 2% means 2% how we can write in fraction? 2 by 100. 2 by 100 means what? 0.02. So 0.02 is our P, means probability of success, probability of defective fuse. And N is number of trials. If we know P, if we know N, we can easily find mean. Mean equal to NP. So N into P is N is 200 into P is 2.0.02. So it's become 4. Now we know the value of M also. M equal to 4. In first question, what? No defective fuse. No defective fuse means what? X equal to 0. So we use the formula of Poisson distribution. Px equal to x equal to 0. In the place of m we put 4 and in the place of x we put 0. After putting this value we got 0.0183 and value of E you know 2.7. After solving this one you can get 0.0183. Okay. And second is 3 or more defective. 3 means we have to take 3 also and more defective fuse also. Means x is greater than 3, greater than equal to 3. X is probability of x is greater than equal to 3. Means probability of 3, 4, 5, 6 up to 200. Means number of trial is 200. So we use Poisson distribution for x equal to 3, x equal to 4, x equal to 5, x equal to 6, x equal to 12 up to 200. But it is a lengthy process. So we use our common sense. Range of probability is what? Range of probability is 1. So we have to minus 1 minus what we don't want. Means we don't want x equal to 0, x equal to 1, x equal to 2. So we have to minus this one. 1 minus p of x less than 3. X less than 3 means what? X equal to 0, x equal to 1, x equal to 2. Okay. Now we use Poisson distribution only 3 times. For p of 0, for p of 1, p of 2. Now 1 minus p of 1 minus probability of x equal to 0, probability of x equal to 1, probability of x equal to 2. We use formula this one, p of x equal to m p power x e p power minus m by x factorial. This is Poisson distribution formula. After using this one and after putting the value, you will get 0.76. Probability of x greater than equal to 0.76. This is the answers. Now this question is completed. This is our last questions of this topic. This is our last questions of this topic. See here, questions number 5. A communication channel receives independent pulses, 12 pulses per microsecond. The probability of transmissions error is 0.001. See, probability of transmission error. See here, very less number is there. No? N is how much? 12 pulse. N is 12. If you compare to N, see 0.001 is very less. So indirectly they said in questions only they said use Poisson distributions. Okay. For each macrosecond, compute the probability of first number is no error during a macrosecond, 1 error per macrosecond, at least 1 error per macrosecond, 2 error, at most 2 error. Okay. See here, n is greater than p, means n is tending to infinity and p is tending to 0. What is the value of n? Value of n is 12. And value of p is 0.01. If you compare this one, see, it's like a p is tending to 0 and n is, if you compare as compared to 1, and n is tending to infinity, So we use Poisson distribution rule. P is 0.001 and n is 12. So what is the value of m? M is NP, right? Mean. So 12 into 0.001 in equal to, we got 0.012. 0.012. Okay. Now we got n. Okay. P equal to Px equal to, we use the formula of Poisson distribution. Px equal to m power x e power minus m by x factorial. This formula. For no error means x equal to 0. No error means x equal to 0. So p of x equal to 0, 0. In the place of m, we put 0.012, and in the place of x, we put 0. After putting this one, after solving this one, use calculator and solve this one. You will get 0.988072. One error means what? One error means p of x equal to 1. We know the value of m equal to 0.012, and x is 1. We put the value in this equation, and after solving this one, we get the answer 0.01186. Now see, at least one means we take the value of 1 or 1 भी लेना है, 1 and more than 1 means 1, probability of 1, probability of 2, probability of 3, probability of up to 12. So this is the very lengthy, we have to use 1 to Poisson distribution for 1, 2, 3, 4 up to 12. So what we did, we used the probability of range of probability is 1. So 1 minus probability of x minus 1. X is less than 1. Probability of 1 minus probability of x less than 1. Probability of x less than 1 means what? Probability of 0. 1 minus probability of 0. Now we use p of x equal to 0. Before only we have to find p of 0 equal to 0.988072. So after solving this one, you can get 0.01193. Okay. Now 2 error. 2 error means what? X equal to 2. We know m equal to 0.012 and x equal to 2. Now we use this formula. And using this formula, you can get the value of probability of x equal to 0.00071. At most 2 error means that number and less than that number. That at least means what? That number and more than that number. At most means that number and less than that number. Here, probability of x less than equal to 2 means probability of 0, probability of 1, probability of 2. For 0 we use formula, for 1 we use formula, for 2 we use formula. After solving this one, you get value of this, and this is approximately equal to 1. So probability of x less than equal to 2 is 1. This topic is completed. I hope you guys are understanding these topics. You guys practice this all questions and solve by on yourself. Okay, thank you. अगर ये वीडियो आपको अच्छा लगा हो तो लाइक करें, शेयर करें, सब्सक्राइब करें और मैथमेटिक्स पढ़ते रहे। दूसरे बाय बाय।